Hello, I'm Mike Allison from Samsung, and I was the lead author of the host managed live migration feature that was ratified in part of the NVMe Express 2.1 specifications that have been recently released. Today, for the agenda, I'm actually going to go over a high-level overview of what that particular new feature consists of. We're going to be talking about migrating a controller, how do you suspend the controller so it stops operation, so that way you can then get the controller state, and then how do you put that controller state in a different controller and then resume operations. Also, as part of live migration there is the ability to migrate any attached namespaces to the controller being migrated, and then how to deal with any dynamic changes of LBAs while you're doing the live migration. And another feature that was added was the ability to track the host memory modifications due to the migrating controller processing commands. So before I get into the full details, what I'm presenting here is live migration really has a set of hosts and a set of controllers in potentially different NVM subsystems. So to help with this particular presentation, I'm color coding these different controllers and hosts to make it clear as to which ones are doing the operations and which ones are pointing or identifying other objects within the system. The blue ones is where the management commands that I'm going to be talking about get sent for the host that's managing the migration, who he sends it to. And then what we're migrating is the migratable controller connected to a VM, which I'm identifying in purple. And I will either talk about the source NVM subsystem or the target NVM subsystem as I go along, and I just wanted to make sure that you understand the format of this. Again, this is a live migration, so what it means is you have a host that you want to migrate along with the controllers that it's sending commands to, and while we're migrating, it's still issuing commands, that is the VM, and the controller is processing those commands as we are doing the migration. So let's just talk about the suspend and resume capabilities and the controller state here. So to suspend a controller, what happens is there's a new migration send command. It's an admin command. That migration send command will identify the migratable controller that is required to be suspended. That command is actually sent to a different controller that is being used by the host that is managing the operation. So as that migration send command comes in for that controller, that migratable controller that we are migrating, it stops fetching commands, it completes processing of all previously fetched commands, and then it halts. Now, as part of halting is just the command processing. Anything on PCIe in terms of the controller properties or any PCIe registers are available for doing transactions. Then we have to deal with the controller state. And one of the problems we have as part of live migration is the ability to migrate between controllers within the same vendor, but different families of products, or even between different SSD vendors. And because of that, we're going to have different versions as we scale the live migration in the future. So one of the things we added was a new CNS value for a controller or an NVM subsystem to report the particular versions of controller state. There are two types of controller state. There's NVMe defined controller state, and we can have multiple versions. So as we do more ratified operations in the future, we can change the state and provide those features for state to be moved as part of live migration. But then there's also a vendor specific area, which we're going to allow UUIDs to identify them, and outside the scope of the specifications, then you can define what that state looks like from a vendor specific. So you issue an identify command, and what comes back is the set of versions that you support, and you may can support one, you may support a multiple of those. Once you understand the versions that's going to happen, that means when you are going to go actually obtain the controller state, for that migratable controller that was suspended, you're going to understand the format. So then we have a migration receive command, which is a new command, which will identify the migratable controller that you want to obtain the controller state of. And that gets then sent to the controller that's managing the live migration, and it returns the controller state. The controller state actually is set up to be more like a log page. It's a, hey, here's all of the state, and you can go read it in one command if it fits. If it's a large amount of state, then that command, several commands can be used with offsets to obtain the whole controller state. Once that MMH has all of the controller state and the controller is suspended, now we can deal with the target NVM subsystem. Now, the target NVM system could be a completely different SSD, could be on a different server. We're agnostic about what type of controllers and where we're going to migrate to. You just get to migrate to any migratable controller. But it is the host responsibility that if it's dealing with a different platform, that it has to send the controller state from one server to the next. The other thing is since we are migrating a VM and a migratable controller, on that target NVM subsystem, we have to have a migratable controller that's not doing work, that is also suspended and waiting to be deployed using the host managed live migration feature. So on the targeted system, it could be a different SSD, for example, and it may have a different way of identifying the versions of the controller state. And so you have to do the identify command also on the target system to know what it supports. Now, generally what's going to happen is the hosts on both the source and target will both do their identify. They'll find a common version that they support, and then that's the version that gets selected. These versions are actually done with indexing, so you'll get a list, you'll identify the number, and the commands use an index to identify which version is going to be done. Once you understand the state of the version that you want to use for placing the controller state, you use the migration send command to identify the migratable controller that you want to place that controller state into, and then you issue the command down. You have the ability to send one or more commands of the migration send commands to set the controller state depending on the size. There is an ordering. We do identify the first one, and then there's a middle, and then a last, and it's up to the receiving controller receiving this message to validate the data before he accepts the actual controller state data. Now, as you can see here, the migratable controller, after setting the state, was turned purple. That reflects the state that from the source NVM target system where it was purple there, now we set the state here. So it is ready to be hosting part of the migrated host once we want to start operations up again. Now, one of the other things is, as part of migration, it's up to the host to make sure that the VM itself gets migrated before we want to resume operations. So there I showed that the host has been migrated by the MMHs, and finally then now he can use the migration send command with a resume management operation, identifying that migratable controller that says, okay, start resuming operations. And when that message comes in, the migratable controller starts fetching commands, and we start processing commands, and that is how a host VM and the migratable controller is migrated in terms of the suspend, resume, and moving the controller state operations. Now, part of doing live migration is there are members that have identified that they want to also move attached namespaces to the VM. And instead of tying this to live migration, we actually created separate commands and alternate ways of doing the attached namespaces, because we found use cases that we could use this capability outside live migration. So live migration can use this feature if moving the attached namespaces is required. So that's why I'm not using the MMH here or the MMC here. It's just a host and controller. But again, it still has the same paradigm where we're using a host that's managing moving the attached namespaces is in blue, and you have the VM and the controller that's up and running and doing commands, and you're trying to move the attached namespaces live. So before we get started here, we want to track the LBAs that are being changed while we're trying to migrate the namespace. So typically what happens is you start tracking changes, then you make a static copy of the namespace to where you're moving it to, and then after you move over the static copy of the namespace, you play back any changes that have happened, and we're going to walk through all of that here. So and we're going to use host memory to put in the changes to the LBAs during the migration. Now, the host gets to submit a new command called the controller data queue. And that controller data queue command is just going into the controller, identifying the controller where we want to track the LBA changes, and then go into the controller that's going to be doing the reporting of those changes to create a LBA migration queue. An LBA migration queue really looks like an IO submission completion queue. It has a head and a tail, and it has entries in it, and those entries get posted by the controller as changes happen. The controller will then return an ID that represents the ID of that LBA migration queue. And I just want to remind everybody that that particular LBA migration queue has a direct association to the controller where we want going to track the LBAs, even though the blue controller is going to be reporting the data. The data is coming from the commands that are being processed by the controller connected to the VM. So now we have the queue, but the host needs to say, start tracking the LBAs. So there's a new command called track send command. That track send command can be sent down. It'll identify the queue identifier for the LBA migration queue and say, start tracking. And when that happens now, every change to LBAs that are attached to the namespaces, one or more namespaces to that controller where we're doing the tracking, are going to be put into this queue by the blue controller. And the first thing that's going to happen is an entry is going to come in that says start. And the start says, I've started logging. So what the host has now is either by the command completing on the start or the first entry in the queue, the host is going to know that logging has started. And once logging has started, you can actually use TP4159, which has been ratified earlier. And this gives you the ability to go to that namespace and determine the static allocated LBAs. So that way, as you're copying the static view of the namespace from the source subsystem to the target subsystem, you only need to copy the allocated LBAs and not the whole namespaces. So what's happening now is you have commands still happening on the host. And as those commands are happening, they're changing LBAs that's in the namespaces. And then over time, the controller is going to identify those LBA ranges that are changing. Now, there is no direct association to the LBA ranges that are being reported into the queue versus the actual commands that are happening between the VM and the controller. So for example, every LBA range reported in the queue could be, in fact, tied to a command. Or if the VM was doing sequential writes, the controller could accumulate and aggregate those LBA ranges and just report one range for the entire sequential write. That is left up to the implementation of the controller. There's no requirements on how that happens. There's also no requirements on the timing between the end of a command and when the queue is posted. Now, we talked about how the controller posts entries into the queue, which causes the tail pointer to move down. Now let's talk about what does the host do with this information. The host's responsibility is to not fill up this queue, and it needs to be pulling entries from the head of it and processing them and copying those LBAs from the namespace that have changed over to the namespace after it copied over the static state of the namespace. And we use the set feature for the controller data queue to say, hey, I, the host, have used entries into the LBA migration queue, and I'm telling you that those are now free for use for future postings there. So this is the way to move the head pointer down there. I'm not going to cover it in detail here. There is ability for, in that same set features command, for the host to say, hey, if you fill a particular slot with the tail pointer with an entry posted, send me an event. So that way the host has the option of getting an interrupt to wake up to deal with the queue, or it can just pull it either way it wants to do it. So that's basically how you do the LBA tracking. Now let's also talk about, hey, the other thing is, as the VM is doing commands, and those commands like a read command affect the host memory, we want to added an optional feature to allow the host to say, hey, start tracking some changes in my host memory as we're doing live migration. And so there's a new track send command that can be used to say, hey, I want to, for this controller connected to this VM over here, I want you to start tracking some memory locations. And the track send command has a set of memory ranges, and those memory ranges addresses are under the same viewpoint as if they were the addresses that are in the read command. It's not tied to addresses associated with the blue host and blue controller. They're the addresses associated and used between the VM and the controller where the reads are happening. So when the track send command comes in, then what's happening is you're telling that controller now to start tracking all of the commands that are affecting host memory. And if they're within the ranges from the track send command, then I want you to remember them. And then I can use the track receive command to have you identify which of those host memory ranges have been modified. So the new track receive command will identify the controller where we're doing the tracking. The track receive command will be sent down to the controller that's monitoring everything, and memory ranges would be sent back to the host. Now, what we have done is those memory ranges could be used exactly by read commands, or I'm sorry, the memory ranges identify those memory locations in the host VM that have been modified. So as the host is actually moving the VM in the live migration use case, he would know which memories to also have to be moved from the VM as it's being migrated. So in summary, for my presentation today, what I've identified to you is that TP4159, the PCIe Infrastructure for Live Migration Technical Proposals, which created a new host managed live migration capability inside NVMe Express, added a new migration send command and a new migration receive command that is used to suspend a controller, resume that controller, and to set and get the controller state. We also added a new track send command and a track receive command to be able to track the changes to LBAs as they are happening by a controller, or to track the host memory modifications due to a controller processing NVMe commands. To support the LBA changes, we've added a new queue called the controller data queue, and there is a new controller data queue command to create that LBA migration queue. And then there's a feature with that to be able to deal with the head pointer changes and to provide a new one-shot event that says, hey, this event happened, I'm going to tell you about it, and then I'm going to forget about it, so there's no history remained in the controller. And we have a new CNS value to identify the supported controller states. Thank you. One thing I would like to say, as part of the SNIA SDC conference coming up in September, I will be doing another presentation on this capability, but I'm going to do a deeper dive. I'm going to go into resets and various other race conditions that we've determined as part of the TP, because this presentation was more of a high-level overview, and I'll be more in depth. I'll also be there available for any questions that you have. So with that, I thank you for your time and attending this presentation.